Now, question number 2, which in this case it's numbered as question 4. So we are given the graph of f of x and g of x. And then we are told that a and b are the x-intercepts of f and c is the y-intercept. D, which is -2 and 6, is a point of intersection between the two graphs. Okay, so we're given two functions, one a parabola, which is f, and then g, our hyperbola. And then now the questions. 4.1, write down the domain of g. Okay, before we begin our questions, let us focus our attention on this hyperbola function. And we know with the hyperbola function, we are expecting a horizontal asymptote. And we are expecting a vertical asymptote. So our horizontal asymptote is defined by the q value, in this case, which is our 3/2. And the horizontal asymptote is the line y is equals to, which is 3/2 there. And our vertical asymptote is defined by the x value, where we look at our denominator. We just equate our denominator to 0. So we'll have x plus 0 is equals to 0. And that means our vertical asymptote is the line x is equals to 0. Now, once we have that, we should be able to determine where our function is defined for the y values and where it's defined for our x values. In fact, we can even fill in the gap. So this is the asymptote. This is what we'll call our y is equals to a 3/2. And then the second asymptote, the vertical one, it's not drawn here, right? But looking at our function, notice that the function of the hyperbola, it's defined everywhere, except that we don't have a y-intercept. And that should mean one thing, right? That means this line, this y-axis, that is our vertical asymptote, the line y is equals to, not y is equals to, rather x is equals to a 0. So our y-axis is also the vertical asymptote. So with that said, the domain of g, our function is defined everywhere, right? Except when our x value is equals to a 0. And then the second question, write down the range of f. The range of f, so f is our parabola, and for the y values, f is defined from this point and moving upwards up until positive infinity. So we need to find what our y-intercept is here, and we can just let our x is equals to 0, and we'll be left with a -2. So that means at c we've got a -2, and the range of f we can say is when y is greater than and equals to -2. And then question number 4.1.3, write down the equation of the horizontal asymptote of g. And I think we've already done this, right? The horizontal asymptote of g, we already have it. That is the line y is equals to 3/2. And then now 4.2, calculate the length of AB. And the coordinates AB being the x-intercepts of f. So to find the distance of AB, let us just write our distance equation. We can say the distance of AB, and we'll have our x at A minus our x at B all square plus our y at A minus our y at b. However, in this case, our y values don't match that much because both y values here are 0. So we can neglect the y part here and only focus on our x-axis, or rather our x-intercepts. So to find the x-intercepts, let us let y is equals to 0 and solve for x. So we'll say 0 is equals to 2x squared minus 2. I can divide everything by 2 just to simplify this equation. So we'll have x squared minus 1. And now let us solve for x. So I'll find the square root of both sides. I will have x is equals to plus or minus 1. So therefore our x at a is a negative 1 and our x at b is a positive 1. And now substituting this into our distance formula there, that means we have the distance of AB, square root of that, our x at B, which is a positive 1, minus our x at, oh, what am I saying? Our x at A, okay, which is a minus 1, minus my x at B, which is a positive 1. All of that squared. The y's don't matter because it's just a 0. So this will be a negative 2 squared, that's a positive 4, square root of 4, that's just a 2. So that means AB is equals to 2 units. And then now question number 4.3. Show that k is equals to 9. And I think there is an error with that question because we cannot have 9 as a positive number. And the reason I say that it's because let us look at where our function is sketched, right? We know that the standard equation of a hyperbola where we have a is defined by x. No, a divided by x. If our a is greater than 0, we are expecting this function to be sketched on the first quadrant and the third quadrant if our a is positive. But the moment we have our a as a negative number, a is less than 0, we expect this function to be sketched in the second quadrant and the fourth quadrant, which in this case we have our function in the second and fourth. So therefore our k cannot be a positive number. That must be an error. So that means we are required to prove that k is equals to a negative 9. And now if ever we attempt 4.3, what we'll do to solve for k, we'll use our given point, which is the point D. We are given that D is minus 2 and 6, right? And our g of x, which is y is equals to k divided by x plus 3/2. Now I'll substitute my coordinate into this equation so that the only unknown I have is k. Therefore we'll have 6 is equals to a k divided by a negative 2 plus 3/2. Now I'll transpose 3/2 to the other side. We'll have 6 minus 3/2 is equals to negative k divided by 2. And now this 6 minus 3/2 is just the same as 12 minus 3, which is a 9 divided by 2 is equals to a negative k divided by 2. And now to solve for k, you can cross multiply or you can just equate your numerators. So we'll have k is equals to a 9. Therefore our k is equals to a minus 9. And if ever you take your k is 9 and substitute into the equation plus 3/2, you should get this sketch of the function. But the moment you make your k is equals to a positive 9, you should have your function somewhere here and there. You can just double check just to verify what I'm saying. So the true value of k should be a negative 9. Now the fourth question, write down the equation of the line of symmetry of G with a positive gradient. So we need to find our line of symmetry for the function of G. So we'll take our asymptotes. We've got the line x is equals to 0, right? So our asymptotes, we've got 0, or rather, let me just say I'm taking the coordinate points where my two asymptotes intersect. I've got 0 and the line 3 divided by 2. So taking that point, 3 divided by 2, and my standard line of symmetry with the positive gradient is just y is equals to x, right? But now our function is shifted. So we'll use those coordinates. We'll say y is equals to x minus 0, then plus 3 halves. So therefore, our line of symmetry is defined by x plus 3 halves. So here I just use my equation y minus y1, and then our m is just 1. So x minus x1, where x1 and y1, it's my coordinate points where my asymptotes intersect, which is this x1 and y1. So this is our solution. And then for the fifth question, write down the values of x such that the function of g of x is greater than the function of f of x. Okay, let me create some room here. Let me remove this. Yeah, this is not needed. So where do we have our function of g is greater than the function of f? So going back to our sketch and checking this, moving from left to right, notice that the function of g is below the function of f when we are coming from the negative infinity up until where the two functions intersect at d. At this point they're equal. And once we continue moving to the right, now the function of g is above or is greater than the function of f. So meaning this is our first valid solution. At this interval, -2 up until x is equals to 0, the function of g is greater than the function of f. And do we have other points? We can check to the right of the x-axis. So the function of f is always greater than the function of g to the right of the y-axis. So that means our only valid solution is between the bounds -2 and 0. So it's when x is greater than -2 and when x is less than 0. And then write down the values of x such that both f and g increases as x increases. Okay, we need to find our x values where both our functions are increasing. And again, checking this, moving from left to right, our function of g, the hyperbola, for all x values except when x is equals to 0, the function of g is always increasing. Look, the function of g is always increasing. It's going up. Even this other arm is going up. However, the function of f on this side of our y-axis, where we have our x values negative, the function is going down, it's decreasing up until that stationary point. And then from x is greater than 0, the function of f is now increasing. So that means our valid solution is when both functions are increasing as x increases. So that means it's when x is greater than 0. Because to the right of these x's, when x is positive, both functions are going up. G is going up, f is going up. So the correct solution in that case, it's when we have x is greater than 0. And we cannot say when x is greater than and equal to, because for one of the function g, x is equals to 0 is not defined. So hence I said it's when x is greater than 0. Okay, now the last question. Describe the transformation of g to h if h of x is equals to 9 divided by x minus 3.5. Now what is 3.5? Okay, 3.5 is 7 divided by 2. So let me rewrite h at x. H at x is equals to 9 divided by 2, 9 divided by x minus 7 divided by 2. So we need to describe what happened to our function of g of x in order to have h at x. So now let me just compare the two functions. H at x is a function with a negative a value. So we've got a negative 9 divided by x, and we have plus 3 halves, right? Okay. So what I think happened with g, let us say, let's just test this, and let us try and reflect our function of what happened then. What is this now? Okay, let me do this, because our a here is less than 0, and then suddenly now it's a positive, so there's a likelihood that the function of g was reflected on the y-axis, right? Because the reflection along the y-axis, we do get a mirror of this function, mirror of g. So chances are g was reflected on the y-axis, and we ended up with a function like plus 3 halves. So in this, a negative divided by a negative will have 9 divided by x, then plus 3 divided by 2. Okay, first I can say my function of g was reflected on the y-axis. However, the new asymptote is now minus 7 divided by 2, and the original asymptote is 3 divided by 2. So chances are function of g was vertically shifted. So we need to find by how many units. So I can say my original function, which is 3 halves plus some y value, resulted in a new asymptote of minus 7 divided by 2. Now what is my y value? Okay, this is just solving for y. Not plus, that's supposed to be minus. So minus 3 halves. So that means this is a negative 7 divided by 2, right? So minus 7 minus 3, that's a minus 10 divided by 2, which is a minus 5. So that means the function of g was shifted 5 units downwards. So let's see if ever we add negative 5, what happens. So I'll say minus 5 here, and then we have 9 minus x, or 9 divided by x, then this will be 3 minus 10, which will give me a minus 7 divided by 2. And indeed, this is my function of h at x. So to describe the transformation of g to h, we can say the function of g, it was reflected on the y-axis, and then it was shifted 5 units down, or rather you can say it was shifted minus 5 units. So that's what happened to the function of g in order to get the function of h at x.